Math 1143, Section 3.2, Exponential Functions. In the first objective, we'll talk about how to graph exponential functions. But first, we'll define what an exponential function is. If we let b be a constant real number that is greater than 0 and not equal to 1, then the base b exponential function of x has the form y equals b raised to the power x. If the base number b is greater than 1, then the graph of y equals b to the x increases. The negative x-axis is a horizontal asymptote, and the y-intercept is 0, 1. So for b greater than 1, I'll just sketch a graph of the general form. If it's y equals b to the x, the y-intercept is always 0, 1. The line y equals 0, that's the x-axis. The negative x-axis is a horizontal asymptote. And then as x values increase, the y values increase very quickly. On the other hand, if the base number b is between 0 and 1, then the exponential function y equals b to the x decreases. And in this case, the positive x-axis is a horizontal asymptote, but the y-intercept is also 0, 1. Okay, so I'll give a rough sketch of what this looks like in general when the base is between 0 and 1. The y-intercept is still 0, 1. You can tell if you replace the exponent x with 0, then b to the 0 equals 1. And it's decreasing, and the positive x-axis is a horizontal asymptote. Okay, we'll graph a couple of exponential functions. First, on the left, we'll sketch a graph of y equals 3 to the x. Remember that every time that you're given a formula for a function, well, it's a way that you can determine what the ordered pairs are on the graph. So if we just pick a few x values and use this formula to find the corresponding y values, then we can plot those points and sketch a graph. Let's start with x equals negative 2. When x is negative 2, 3 to the negative 2 is 1 over 3 to the positive 2, which is 1/9. So when x is negative 2, the y-coordinate is 1/9. If x is negative 1, then we're going to get 3 to the negative 1, which is 1/3. If x is 0, we're going to get the y-coordinate 3 to the 0, but that's 1. And when x is 1, the y-coordinate is 3 to the 1st, or 3. And when x is 2, the y-coordinate is 3 to the 2nd, or 9. Okay, so we'll get a rough sketch of this. So we'll just plot a few points. The y-intercept is 0, 1. Negative 2, negative 1, 1, and 2. So this is 1/9 is the y-coordinate, then 1/3. And when x is 1, the y-coordinate is 3. And when x is 2, it looks like we're off the grid already, but Since the base is 3, which is greater than 1, the exponential function is increasing. The next example, y equals 1/3 to the x. This base number is between 0 and 1, so we're expecting it to decrease like what it does up here. Okay, so we'll pick -2, -1, 0, 1, and 2 for the x values again. And over here I'll have my x and y coordinates. When x is -2, 1/3 to the -2 is equivalent to 3 to the +2, which is 9. When x is -1, 1/3 to the -1 is equivalent to 3 to the +1, or +3. When x is 0, 1/3 to the 0 is 1. And when x is 1, 1/3 to the first power is 1/3. And when x is 2, 1/3 to the second is 1/9. Okay, so we can plot those points. So -2, the ordered pair -2, 9 is off the grid. The ordered pair -1, 3 is about right there, -1, 3. 0, 1 is the y-intercept. When x is 1, the y-coordinate is 1/3, and when x is 2, the y-coordinate is 1/9. So the graph decreases as x approaches infinity. And in both cases, in this function over here, the negative x-axis is a horizontal asymptote. And for this function, the positive y-axis, or the positive x-axis, is the horizontal asymptote. Okay, we'll sketch a graph of a more complicated situation. So this is an exponential function that involves horizontal and vertical translations. So on this one, notice the +3. That's going to push the horizontal asymptote up to y equals 3. So the horizontal line y equals 3 is a horizontal asymptote. It's going to be for the negative x values. But one strategy, besides just doing horizontal and vertical shifts, is just to plot a bunch of points until you know what the graph looks like. So why don't we do that? We'll strategically pick some x values, and then in the function replace x with those values, and then do the arithmetic to determine what the y values are. So I suppose what I would do, since the exponent is x minus 1, I'm going to pick my middle x value to be 1, and then I'll pick a couple of numbers smaller than 1, like 0 and -1. And then I'll pick a couple of numbers larger than 1, like 2 and 3. Okay, so when x is -1, the y value is 2 to the -1 minus 1, or 2 to the -2, which is 1 over 2 to the second, which is 1/4, and 1/4 plus 3 is 3 1/4. So that's just above the horizontal asymptote, 3 1/4. The ordered pair -1, 3 1/4. I'll write it as an improper fraction. It's 13/4. And then when x is 0, replace x with 0, we get 2 to the negative 1, which is 1/2, and 1/2 plus 3 is 3.5. So the y-intercept on this one is 0, 3.5, but I'll just write it as 7/2. Okay, when x is 1, replace x with 1, we get 2 to the 0, which is 1, and then 1 plus 3 is 4. So when x is 1, the y-coordinate is 4 right here. Then when x is 2, replace x with 2. 2 minus 1 is 1. 2 to the first is 2. 2 plus 3 is 5. So the ordered pair 2, 5. So that's... Okay, then that's enough to know what the graph looks like. It's increasing, but it's important to remember that the horizontal asymptote is y equals 3. Okay, the next page. Now we're in objective 2. This one says evaluate the exponential function base e. So the exponential function y equals e to the x is called the natural exponential function because its base is the natural number e. The natural number e is an irrational real number. Its approximate value is 2.71828, but its decimal expansion is non-repeating and non-terminating. That is true of all irrational numbers. It's the case that you can approximate the number e if you pick m to be large in absolute value, and then evaluate 1 plus 1 over m raised to the power m. So this will be approximately 2.71828 if you pick m to be large in absolute value. Okay, we'll graph y equals e to the x. So this is going to be increasing because the number e is greater than 1. And e to the 0 is 1, so the y-intercept is 0, 1. And then when x is 1, e to the first is 2.71828 approximately. So it's about right here. And the negative x-axis is a horizontal asymptote again. Okay, so that's a rough sketch of y equals e to the x. This one involves a horizontal shift of 2 units and a vertical translation downward of 1 unit. So what this does is it lowers the horizontal asymptote to y equals -1. And then if we just follow a couple of points on the graph of y equals e to the x, we have 0, 1. So this tells us to move that point 2 to the left, and -1 is move it down 1. So we're at this point. And this point, which is 1e, that's another way to think of that, 1e. So we shift that 2 units to the left, we're at -1, and then e minus 1 is about 1.7. So it's about right here. So roughly, this is what the graph looks like.